Let's take a bit of a look at another kind of loop here, the for loop. So what we were just doing in the earlier video is that we had a list here of ice creams, and we used a while loop as a way to iterate or to visit every element in that list. Just as a little bit of a refresher, there are these three parts that we have to control, right? So one of them is the initial status. We're starting at drawer 0. The other is a Boolean test. So as long as the index that we're using is less than the length of the list itself, we know we're good. The length of the list is 5, but there is no drawer number 5 because the drawers are numbered 0 to 4. So as long as the index is less than the length of the list, we're still iterating properly. And the last one is the degree of change. We all know already that list indexes go up by 1. That is an increment. Now this is just a fancy way, a fancy shortcut to write index equals index plus 1. This is something that you'll see really commonly in Python. I actually kind of use it a lot. I'm fond of it. This works with all the math operators, with star for multiplication, division, addition, subtraction. Even works for concatenation, right? Plus is what we call overloaded. It works for strings as well as numbers. So that's a little bit of a shortcut. You'll probably see that a lot. Now, this is perfectly acceptable. We can always loop through a list this way, but Python said, well, look, this is something that's really common. And so what Python did for us is to make a very, very, very simple loop that automatically does all three of those things for us. Controls the initial status and the Boolean test and the degree of change all at the same time. It is neat and tidy and small and nice. And it is called a for loop. Here's what it looks like in Python. Imagine ice cream is defined the way that it was, right? I'm not going to repeat that line. All we have to do is write for some new kind of temporary variable in the list called ice cream, print the value of that new temporary variable, whatever we've called it. Here, I just call it flavor. Kind of makes maybe some sense. Now, under the hood, Python's doing all three of those things for us. It's keeping track of the indexes. It's making sure we don't fall off the end of the list. It's doing the increment for us automatically. So none of those things we have to worry about. Now, I'll do a little animation here about what happens. So you'll see down at the bottom, there's this bucket called flavor. I could have called it anything. I could have called it variety or who knows what. This is a random name. But what happens is, as Python iterates the list or moves through the list, one by one, the value of each drawer is copied into this bucket called flavor. So at first vanilla gets copied in there, and then mint gets copied in there, erasing vanilla, and then cookie dough goes in, erasing mint, strawberry goes in, erasing cookie dough, and Neapolitan goes in at the end, erasing strawberry. So flavor gets overwritten a lot, and it's kind of a temporary, almost throwaway variable, right? We don't necessarily need it. We need it temporarily because the for loop requires us to put those values somewhere. But then we can do something with it. But it's not flavor is maybe not necessarily one of the long-term standing variables we want. Maybe not, right? Now, that bucket that we copy all of the list items into is an arbitrary name. However, I just wanted to point out that you'll often see an interesting pattern. That is to say, you'll often see a for loop written as for some singular thing in a list of some kind of plural thing, right? Like this one. We might have a list of letters of some kind, and in the for loop, we copy each of those values into a temporary variable called letter. This is a really common pattern, and I've been teaching Python for a long time now, and one of the things that often happens at this point is that people say, well, I understand there's a relationship between letter as a singular thing and letters as a plural thing. So does Python do this automatically because one is singular and one is plural? And the answer is no, it doesn't. So Python doesn't care what we call any of these things. So I could call letter banana if I wanted to, and that's fine, or character or glyph. I could write for banana in letters, print banana, and Python would be perfectly happy with that. So we think about like semantics. Semantics is the meaning of a sentence or the meaningful relationship of terms, but there is no semantics here. Python doesn't understand semantics. Here's another one for person and people. Does Python know that person is the singular of people? No, it has no clue. The only way that Python knows to iterate the list called people and to dump those values into a new bucket called person is that we've named them here. That is it. So we need to have a bucket so that Python can iterate the loop, but it doesn't care if we call that person. We could call that robot, or we could call that individual, or, if you happen to be one of those people who has friends, you could even say for friend in people. So it's useful for us as humans to choose meaningful variable names. And in fact, I like to choose these singular in plural kinds of variable names because I find them quite meaningful and illuminating. But don't make a mistake of assuming that Python is going to do something for us automatically simply because these words are related. That is not the case in any way, shape, or form. All right. But just a caution, not a caution, just a note. As we go forward, and I start writing some for loops, I will often rely on this for a singular thing in a greater collection of plural things. That's just a variable naming pattern that I will use a lot. All right. Now we saw two. This is what we're going to play with in the terminal window here at the end of this little lecture. We played a little bit with the in operator, and one of the things that we noticed is that the in operator looks at a dictionary's keys, and it doesn't look at a dictionary's values. That's maybe not intuitively obvious, but it's just the way that Python does it. The flip of that, the reverse of that, is that in looks at a list's values, but not its indexes. When we work with a for loop, it's exactly that same pattern. So the default iteration of a dictionary is to iterate the keys, but not the values. And the default iteration of a list is to look at the values, but not the indexes. So if we want more information, we just have to go one extra step in order to get that. So if I just wanted to iterate the values of a dictionary, I would write down the name of the dictionary or the variable that I've put that into and then put .values at the end. That will return to me the values and I can iterate the values. If I want both the keys and the values at the same time, I use this other one called .items. And we'll see how this works here in just a second. And I might go down slightly a little more technical maybe than you might want, but that's okay. I'll show you this. Now, the same thing with lists. Because lists look at values but not the indexes, if I ever do want the indexes, I'm going to use this standalone function called enumerate. I'll show you that here too in just a second. But notice that there's a little bit of a difference here. And we'll talk about this in one of the upcoming slideshows when we start to talk about objects and we start to talk about functions. This does not have a dot on it. It is a function and not a method. So this is not a thing that lists know how to do. Enumerate is a standalone entity unto itself. So I must send to the enumerate animal a list. I'll show you that here in just a second. So here's one straightforward way to get the values out of a dictionary. This is really, really similar to what we did when we were playing with a while loop a little bit earlier. So here I've got my English to Latin dictionary defined just as we did before, and now you'll notice that I'm using a for loop, but we know that for and the in operator only look at the keys of a dictionary. So I've made a temporary bucket here called key. Could I have called it banana? Yes. Just because I called it key doesn't mean that I am telling Python to put the keys into that value, into that variable. I could call it banana, I could call it goofus, I could call it bird, I could call it anything I want to. It doesn't matter what I call that variable because it's only temporary. But then what I'm doing when I'm in my print statement here is I'm saying look in the dictionary called English to Latin, and whatever the value of key is, go look in that drawer and print the final value. So if key is a bucket over here, I'll put it way over on the side, I'm going to copy values in there and then overwrite and overwrite and overwrite. So at first, tree is going to go in there, and then bird will go in there, and then wine will go in there, and then at the end, truth will go in there. So these are the 4 keys in the English to Latin dictionary. And so when I want to print the value, I tell Python to go into print, look in the English to Latin dictionary, go in the drawer called tree, and then print whatever you find there. Go in the English to Latin dictionary and find the drawer called bird and print whatever you find in there. Right? Now, I'll say this. You'll notice that truth is just kind of left over there in the end. That's okay. It doesn't really matter. It was just truth. Truth happens to be in key at the end simply because it never got overwritten with anything else, right? So we'll try this out in the terminal window at the end. But if you like, obviously all the way through, if you want to pause and play with this at the time, go right ahead and work on that. Now, if I wanted both of those, if I want both the key and the value, I can ask the dictionary to give me its items. And so I write English to Latin dot items brackets or parentheses. And what I get back is a list of, well, I get a little complicated, but I get back all of the tree arbor pair, bird avum pair, etc., etc., etc. And in fact, if I take that and do English to Latin, and I do that just in the terminal window, here's what I'm going to get. Here's my 3 prompts, for the Python interpreter shell. And give me English to Latin, give me all of the items. And you'll notice that I get this thing. It says a dictionary items. And what I really get here is a list of tuples, right? So the square brackets mean a list. The list has 4 items in it. And I get each of those items in the list is a tuple. The tree arbor tuple, the bird avum tuple, etc., 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 all of the way through. So now I'm going to dive a little bit deeper. And what happens is each of those items, like tree will get copied into key, arbor gets copied into value, and then the next iteration, bird gets copied into key, avum gets copied into value, and then I can print those out to the screen. But under the hood, here's a little bit more about what happens. I mentioned to you that tuples, it is true, are immutable lists. And we can't change them. But there's a second cool thing that Python does with tuples, which is that it allows this funky kind of parallel assignment. And this is actually what's happening here under the hood. So, again, if you want to see, just skip ahead. You don't want to hear all of these details. That's okay. Key value is actually a tuple. If you remember back in an earlier video, I said we can make a tuple even if we don't use parentheses around it. That's true, and here's an example. So key value, believe it or not, is actually a tuple. And so what I'm doing is a funky kind of tuple assignment. So the tuple on the left, composed of key and value, will be set to be equal to the tuple on the right that happens to have parentheses called tree and arbor. So you can see the color coding there, and I'll put some arrows in just to see what's happening. So the 0th element on the right gets copied into the 0th element on the left. So the value tree goes into the key. And similarly, the 1th element, arbor, gets copied into the 1th element on the left, which is value. So this might be a little bit more of a detail than you really want, but the magic that makes the for loop happen here is actually a tuple. And it's this funky, cool property in Python about being able to copy or assign multiple things all at once. That's really pretty cool. Lots of times this is just kind of demonstrated as a parlor trick in Python. But if you're really curious and you're really interested in how this works under the hood, it's the magic of tuples that actually makes the for loop possible. All right, one last slide, and then we'll jump into the terminal window and do a little play. This is the same thing, just working with a list. And so if I needed to look at both the indexes and the values of a list, what I would need to do is send the list to this freestanding function called enumerate. Enumerate is not part of a list. It's not a thing a list knows how to do. It's something separate. And so we give it a list and it says, oh yeah, I know what to do with, I know how to do that with a list. But you can see the same thing here. I'm copying it into index and value. But again, just to repeat, we'll play with this in the terminal window here in a minute. But notice that this enumerate is what we call a standalone function. So I am actually sending, it's sort of like a delivery service. I am sending to enumerate a list called ice cream, and what we get back are these tuples of indexes and values. All right, well, let's take a minute now. We'll just jump into the terminal window and we'll play with these a little bit. All right, well, here we are back in the terminal. I guess I'm just feeling a little bit matrixy today. I wanted a different look to the terminal. I do like the blue one, but we'll just go with this one today. So I'm going to just jump back into the Python command line interpreter, and I've already taken the liberty of typing out some of the stuff. So we're going to look at that for loop first with ice cream. I'm just going to paste that in here. You can see that I'm working on ice cream. I've got, obviously my 5 different flavors, and now I'm doing a new loop here for flavor in ice cream, and I'm just printing the flavor. So when I hit return here a couple of times, I have to hit return once so that Python knows that I don't have anything else, and the second time I hit return, it will execute that loop. So this happens all the time with indentations, but you'll see that we'll get those 5 flavors right there, all in order. So again, what happens is it's the for loop is taking control over the indexes, the incrementation, the Boolean test. It knows now how not to fall off the end of the list. And then we're copying all of those into a temporary bucket called flavor, and then I'm just printing that to the terminal window. That's it. If I ask it right now what flavor is, you'll see that it's still Neapolitan. And that just makes sense, right? Because flavor gets overwritten every time we go through the loop. But because Neapolitan does not get overwritten by a later value, it just is sort of like the residue, right? It's the ring around the bathtub before we get going. All right. Let's take a first look at that dictionary. I've got some more code here, so I'm just going to paste that in again. You can see at the top here that I've created my English to Latin dictionary, and there's just a blank line, so I get my 3 arrows. And then I'm putting in my loop here for key in English to Latin, and then I'll print that out to the screen. Again, when return, just to give Python something, it's going to notice that I don't have a new indent. So there you go, I've run it. So now you can see that what I'm doing is copying all of the keys from English to Latin into this throwaway variable key, and I'm just using that in order to print the values, right? So I get all of the Latin words, arbor, avum, etc., etc., etc. Now, if I look in English to Latin and I ask for the keys, I'll get that back, and you'll notice that's just a list. So ignore that dict keys thing. It's just a list inside there, and we know we can iterate a list, right? So this is actually what the for loop is doing. It's iterating for key in this list called tree, bird, wine, truth, right? That's actually what it's really doing under the hood. I can ask the dictionary for its values as well, and you see that's just another list, arbor, avum, etc., etc., etc. And if I ask for the items, I don't even have to type the whole thing, you can see now that I get a list of tuples, right? So they're matched pairs, tree, arbor, bird, avum, etc., etc., etc. So what I can do now, I'm just going to type this one out for key and value in English to Latin items. print key, see I need a plus, is value. There you go. So tree is arbor, a bird is atom, etc., etc., etc. So this is the way that I can look at both the keys and the values in a dictionary. I need to use this, what we're calling a method, this items method, which returns to me those pairs as tuples. But again, keys, values, items, all these are things that a dictionary knows how to do. You can think about them as verbs in some sense. Like, hey, English to Latin, give me your keys. English to Latin, give me your values, etc., etc. So we call these methods because they belong to a class of objects called dictionaries. So in the future slideshow, we're going to talk a little bit more about objects, what those mean, how we get those out. There's one more. Let's take a look at one more. All right, this last one. Oh, I cleared my terminal window. Let me just get back into Python. Okay. So this time, let me just paste this, and you can see what's happening. So I've gone back to our old friend ice cream, and now I'm going to use the enumerate function. I will send to it the list called ice cream, and that will return a series of tuples of indexes and values. Now I'm going to print this the same way I did before, and I will get an error, but that's okay because I want to talk through what's happening. So when I get these back, index is going to be a number, isn't it? It's going to be 0, 1, 2, 3, 4, 5. Okay, well, like 4. But value is a string. Now look what I'm doing in this line, right? I'm adding all of these things together, but index is a number, and then I'm trying to concatenate onto the end of a number a string, and then I'm concatenating onto the end of it another string. So what's going to happen is I'm going to get an error, and Python's going to say, look, guy, I don't know what you're doing. Some of these are numbers. I know how to add numbers, but some of these are strings, and I know how to concatenate strings, but you're mixing them up, and now I'm really confused, and I don't know what to do. So there's my line. So I get a type error, unsupported operand for plus. I have both an integer and a string in there, and so that is a mistake. This is a mistake of a data type. So here's what I want to do to fix that. I'm going to go back. I'm just going to hit the up arrow in my terminal window, and I'm going to get this line, and I'm going to go up, and I'm going to get this one, but I'm going to change something here. So here's what I'm going to do. I'm going to just put a space in here, and I'm going to type string, and then index, like so. So here's what I'm doing, which is that I am taking that index, and I am turning it into a string. And this is called casting. We talked about this a little bit before. I like this metaphor of casting because I'm like melting down that number and I'm pouring it into a new mold where I'm turning it into a string. And now Python should be fine because it says, oh, okay, I have a string and I'm concatenating a string and I'm concatenating a string. Not a problem. Everybody seems to be of the same data type, so I am going to be quite happy. And there we go, right? 0 is vanilla, 1 is mint, etc., all of the way through. So the property called, or the value called index, let me be more precise. The value in the bucket called index used to be a number, well, it still is a number, but temporarily I am converting it into a string solely for the benefit of the plus sign. Now, if I ask what's an index right now, I get the number 4. And if I ask, hey, what is the type of the thing in index right now? It's of class integer, right? So this conversion from a number, an integer, into a string is only temporary. It only happens right there in the print statement, but the value in the bucket index remains a number. And that seems important. It actually is important. But you probably get this a lot. As soon as we start mixing numbers and strings, Python is going to give you a type error. And the cause of that problem is what we call the overloading of the plus sign, because the plus sign works both for numbers and for strings. But Python is not going to convert from one of those things to the other just to make your life easier. So sometimes we have to take matters into our own hands and we have to cast that. And that's exactly what I've done here. All right, thanks. All right, well, next up we're going to talk about objects, and we're going to talk about compressions, which are a spiffy way to initialize things like lists and dictionaries.